Welcome to our KNES 361 video analysis project. The first example we're going to show is a car tire jack and how mechanical advantage is being used. Okay, so let's see how all of this works. It's all because of what's called a mechanical advantage. This means that the mechanism we are using to do the job requires less energy and muscle from the person to accomplish something. You have been using mechanical advantages all the time and may not even know it. Some examples are the wheelbarrow, pliers, nutcrackers, and bottle openers. A Class 2 lever is what allows for mechanical advantage. A lever arm rotates on a fixed unmoving axis called the fulcrum, and the effort is applied to the furthest segment from the axis to make the lifting load in the middle easier. The closer the load is to the fulcrum, the easier it is to lift or move. Now let's apply this to the actual hydraulic car jack. Let's focus on the lever system on the right first, the part where the person applies a force on the arm. The green piston in the diagram is filled with fluid. When the effort is exerted downward on the arm, the piston, although much harder to move, is pushed down as well with the mechanical advantage. This forces the fluid through a one-way valve called a check valve. The fluid fills the chamber a little bit more each time the arm is pushed down. This builds up pressure in the chamber and moves a larger piston outward, which moves the load arm of the jack outwards, which eventually lifts the car. Our next example is going to include how a cardboard box sliding down a hill includes friction and how they work together. Let's talk about friction. Friction is a force that acts on surfaces in direct contact with each other. These forces act in opposite directions from each other, and this is an example of Newton's third law. For every action, there is an equal and opposite reaction. These forces act in parallel surfaces to each other. Friction depends on two things, the coefficient of friction and the normal force. Normal force can be described by when two objects touch, they exert a force on each other. In this example, there is the weight of the person on the ground, and the ground then exerts an equal and opposite force back on the person. The coefficient of friction describes the relative ease of sliding between two surfaces. Things that affect this are the roughness and the hardness of the surfaces. The lower the coefficient of friction is, the easier it is for the two surfaces to slide against each other. Let's apply the principles of friction to cardboard hill surfing. Going back to the formula in the previous slides, normal force in this case is the weight of the person sitting on the box and included the weight of the box. The coefficient of friction in this case is determined by the interaction of the cardboard and the grass. This would decrease if the grass was wet, or if we took it extreme if the grass was covered in snow. If we wanted to decrease the friction, we would have to either decrease the natural force by maybe switching another person who weighs less, or we would have to decrease the coefficient of friction by making the contact between the box and the grass smoother. Thanks for watching our video analysis project. We hope you enjoyed our presentation.